The course objective is to learn to process big data with Hadoop and Spark. All right, that's the core objective of this course. All right, so before we go ahead, let's learn basic terminologies. The first important terminology is structured, unstructured, and semi-structured data. So we start our uh, when we talk about big data, before that we talk about the data variety. So let's take one at a time. So what does it mean by structured data? Structured data is something in a tabular form, just like in a database. In a database, we have data in the form of a table. It has rows and it has columns, and all the values in the same column have the same data type. Okay, that's called structured data. Structured data has perfectly defined schema. It has columns, and we have a clear we have a clarity on each of the columns data type, right? That's called structured. Now, structured data is popular. Why? Because on structured data, we can simply run queries like SQL. SQL means structured query language. Okay, SQL stands for structured query language. Therefore, therefore, the name is structured. Now, on the other extreme is unstructured. In case of unstructured data, we have no clue about columns. For example, if you have plain text data, or you have, let's say, some raw data in fixed file format, or some raw data from, let's say, some sensors, right? That basically is unstructured. Unstructured can be converted into structured by the way of ETL. ETL stands for extract, transform, and load. Similarly, to convert on the midway is semi-structured. Semi-structured data is the data in which we have somewhat idea about the structure, but it is not strictly tabular like the structured data, right? So when the data is perfectly, we have a clarity on each column's data type, and we have a clear segregation of the columns, that's called structured. And we don't have columns, it's called unstructured. If we have columns and some way we know the structure, that's called semi-structured. All right, so basically to convert semi-structured or semi-structured data into structured, or to convert unstructured data to structured, we use a process called ETL. There are many ETL tools out there, such as Informatica, such as Microsoft ETL tools, and so on. But when it becomes when it becomes the data becomes bigger, then we use the Hadoop and Spark kind of ETL tools. All right. Wonderful. So the next term that we are going to use over and over again is distributed systems. Okay, what does it mean by a distributed system? Distributed system is groups of networked computers that interact with each other in order to achieve a common goal, right? So here the most important part is the third one. When you have networked computers that you have all anyway, like you go to a computer center, there are networked computers, but that's not a distributed system, right? A distributed system is one in which there is a common goal to achieve. Okay, or you can say that you have some task to perform, and you divide this task amongst many computers to get it executed in the fastest manner. That is distributed computing. Now, question to all of you is, just to check if you are awake, how many bytes are there in 1 PB? Yes? All right. Okay. Jiang is suggesting this is around 10 to the power 40 bytes. Are you sure about it? So you have bit that is on and off. You have byte that is 8-bit, right? And then you have kilobyte, which is 1024 bytes. Then you have megabytes, which is 1024 kilobytes. Then you have gigabytes. Then you have, after giga is tera, and then comes peta. So how many zeros? Okay, that's right. That's right. So it's basically, most of you are correct. And yes, it's basically 10 to the power 15. Okay, it's basically 10 to the power 15, close to 10 to the power 15. Wonderful, wonderful. Looks like everybody is listening. Now, next question to all of you is, it's another trivia. It's okay to be wrong here. All right. How much data do you think Facebook stores in one day? How much data do you think Facebook stores in one day? Anyone? All right. Okay. So it's okay to be wrong. Right. Thank you, Mac. So it's close to 600 plus terabyte. That this data is again probably a couple of months old. Maybe newer is different. All right. So basically, Facebook stores 600 terabytes data per day. That means if you have 1 terabyte hard disks, they're going to consume around 600 such hard disks per day. Now, the next question to all of you is, what do you understand by big data? What is your definition of big data so that we can come on the same agreement that the definition of big data? Yes? Anyone? What is your definition of big data? Good. Rohit's answer is huge data, data which cannot be handled by traditional tools, voluminous, variety, and veracity. All right. All right. Keep going. Okay. All right. Great, great set of answers. A question in between is from Jiangi that I heard auto drive car processes 1 petabyte per day. Could that be possible? Very good question. I think that question is going to get answered probably after 3 slides. All right. So be with me for next 3 slides. Wonderful set of answers. Wonderful set of answers. So in simple words, data of very big size, the huge data. All right. Big data is not a tool. Big data is not a solution. Big data is just data of very big size, right? Second is the kind of data that you cannot process with usual tools. Now here, you might wonder what it means by usual tools. Nowadays, Hadoop is usual, right? But here, the usual term, usual tool means the tools like your normal file system or normal relational database. Thank you, Kiran. Now, the most important part of this definition that we're going to stick to is distributed architecture needed. The purpose of big data tool is to get the work done using multiple computers. When your data becomes so big that it cannot be handled by a single computer, no matter what kind of software do you use, then we call that data as big data. And you will wonder that probably every kind of data can be handled by computer, a single computer. No. Let me just go into more details about it in a minute. Now, when your data becomes so huge that you cannot get the work done, the desired work done in correct time using a single computer, no matter what kind of computer do we use or what kind of software do we use, then we call that data as big data because for that kind of problem, you will require multiple computers and you will have to divide this data onto multiple computers to get the work done using distributed architecture. All right, so this is where the definition of big data comes in. So keep in mind that all the components that we are going to discuss in this course, all of the components are big data components because they are distributed in nature. All the components, whether you talk about HDFS, Yarn, Flume, Scoop, and so on, Spark, everything is distributed, meaning getting the work done using many computers. So you can say that this course is about distributed computing. All right, we're going to talk about all the components in this course which are distributed. Now your data could be structured, unstructured, or in whatever form. If the data you're not able to process using a single computer because of time and time constraints, then that is, and you require a distributed computing, then you call your data as big data, whether it is structured, unstructured, or semi-structured. Now, what are the characteristics of big data? These are the common characteristics of big data: volume, velocity, variety. When the data is at rest and when your problem is around the volume, meaning you are trying to figure out that, hey, this is a humongous data and we need to store it somehow, right? Then you call that the big data as big data by the virtue of volume, right? Say, for example, you are doing a storage of logs of your website, which are really humongous. In that case, you would require a big data platform, right? Similarly, if you think about how many emails Gmail is storing, right? That's like huge. It's like more than maybe like more than Facebook, like hundreds of petabytes of data, hundreds of terabytes of data. It's storing onto somewhere, right? That problem associated with storing such a huge data is called due to the volume of data. The second form of data is velocity, meaning the data in motion. When the problem that you face is associated with the velocity of data, meaning when the data is moving from one place to another, it moves by the way of current, right? So when you are not able to handle those many requests or transmit that much data, we call that your problem is related to the velocity, right? Say, for example, number of requests that being handled or received by Facebook per second, or the amount of data that YouTube is serving to the world at every second. The Google Analytics is receiving millions or billions of requests from the users because almost every website puts the um, code of Google Analytics into their page. Let's say when you visit CloudxLab.com, a request goes to Google Analytics to mark that you have visited our website. All right, just to know how many users are visiting the website, what is the page flow, what page does not look good, why, on which page are people dropping off. That's basically Google Analytics. So Google Analytics, if you think about it, they will be receiving hundreds of millions or billions of requests per second, right? So problems related to number of requests or the amount of data that need to be transferred per second is called problem related to velocity, right? So data could be in motion, and that's what is the second property of the data. Now, the third one is variety meaning the data in various forms. So this is a very interesting characteristic of the data. So data could be in many forms. Now, interesting part is sometimes the problem statement is so complex that even when there's no velocity involved and no volume involved, if your problem statement is complex, then also, even if your data is small, you end up using the distributed computing. All right. So say, for example, if you have a map in which you have to go from one point to another, there could be many permutations that will be involved. And therefore, even though the data could be smaller in the size, but since the problem is complex, it would require a lot of computing, and hence the problem would become the distributed computing problem very soon as number of users increase. All right, so the next question to all of you is how much time is taken to read 1 TB from hard disk drive? Anyone? It's very important because here, when I'm walking you through these questions, so what I want to do is I want you to develop a common sense around these basic tools. Okay, so common sense is not common when it comes to technology. Therefore, these kind of questions generally guide you to get a feeler. When we say do the back of envelope calculation as even as a non-technical person, then these questions help you. All right. Even if you think that your answer is completely wrong, even then, please post your answer. Question to all of you is, how much time does it take to read 1 TB from hard disk? Is it a function of the processor? Is it a function of memory? Or is it just the function of the hard disk? Okay, just an approximate answer. Yes, it is basically a function of hard disk speed. Thank you. Ayendra? Perfect, perfect. Also, it also depends on what kind of connector are we using. So it takes close to 6 hours. Sometimes the time varies from 6 hours to 10 hours or 12 hours, or it could go even to 4 hours, depending on the kind of hard disk are we using. Also, what kind of connectivity is there, and so on. So basically, the important part here is that somehow we believe that reading the data from hard disk takes only few minutes, and only the processor is the one that matters. The answer is hard disk matters the most when it comes to big data. All right. All right. Now here is a hard question. So, and this is a hypothetical question, by the way. Question is, if you have to just count vowels in 1 PB text data, you imagine that you somehow stored 1 PB data. Now, and you have to count these count the vowels in that 1 PB data every day. Do you think you need a distributed system? Anyone? Imagine that you have somehow got this wonderful hard disk having 1 PB storage, and in that you stuffed 1 PB data. Now, when you are reading the data from it, all you need to do is just count the 5 numbers, how many times the vowels are occurring, right? There are 5 vowels, so you will keep count 5 counters and read the data from left, from the beginning to end, and you will basically check if it's a vowel or not, and then you keep an increasing counter. Now, here, this task is not processor intensive. Even if you are using a low-end processor, the speed is going to be similar. Now, question is if you have to just count vowels in this 1 PB data every day, do you need distributed system? Okay. Yes, thank you, Anurag. So it's going to take around 6,000 hours on a single computer. Therefore, you would require distributed system. So the suggestion is, whenever you face a challenge, you should generally do your back of the envelope calculation and say that, yes, this is a big data problem. No matter what tool you use, you will end up utilizing multiple computers. You will not be able to solve such problem using a single computer. So this is back of the envelope calculation you would require. Now, a question from Samya is, it depends on how fast you need that information. Here we're talking about every day. So it's definitely not possible using normal hard disk and normal computer in one day, right? Right. So basically, correct. Thank you, Manish. Wonderful. So basically, such kind of problems cannot be solved using a single computer, and you would require distributed computing environment. All right. So a very common question is, why big data? Why people are talking about it? In simple words, the data, specifically the digital data, is being stored more and more after probably 2002. So you can see that after 2002, there was exponential increase in the digital storage, right? While the analog storage, such as paper and film, that one has been decreasing continuously. Okay, so here basically the point we are trying to make is that after 2002, the digital storage has been increasing exponentially, right? And why is it so? The answer can be dedicated to devices and connectivity. On one hand, the devices have become cheaper, faster, and smaller, and the connectivity has become omnipresent and faster. And the multiple of two, the devices multiplied by connectivity, has led to a lot of innovation in terms of software, right? And hence, there are so many applications, and each application gathers a lot of data. So if you think about it, every year the devices are becoming cheaper, faster, and smaller. On the other hand, the connectivity, Wi-Fi, 4G, NFC, and GPS, along with Bluetooth, is improving every day, and that has led to tremendous apps, tremendous innovations in the data storage, right? So you can imagine that the mobile phone that you have right now with you is is magnitudes faster than the supercomputer of 2002, right? So yes, the phone that you use for playing Fruit Ninja or Angry Bird or Temple Run. So basically that phone is faster than the supercomputers of 2002. All right. So the phones or the devices have become cheaper, faster, and smaller. These are the three criteria every hardware company abides by. The three criteria, the three objectives are cheaper, faster, and smaller for any hardware company. All right. So basically, this is one of the reasons, because of so many hard innovations in hardware, which has led to the plethora of applications, and that has led to humongous data. Right now, let's just take a look at what does it mean by computer conceptually. Okay, we are not going to go into the detailed view on the hardware. We're going to just talk about these four basic components that matter in computing. The first such component is CPU. In case of CPU, what is CPU? CPU basically takes the instruction, and based on that instruction, it reads data from somewhere and puts the data somewhere. That's all CPU does based on the instruction. CPU is the one that takes your code and executes it, as in you get when you are writing code, the instructions that you write are for CPU. Okay, so CPU is going to read that, and more number of instructions it can handle per second, or more number of steps it can take per second, is basically its frequency. Okay, that's how we say that CPU is faster or slower. Okay, based on the frequency. The second one is RAM. RAM is random access memory. RAM has two characteristics: how fast it is and how big it is. So most of the data is kept in the RAM, and the CPU reads the data from the RAM. Also, it stores back the data in the RAM as well as in the disk, but most of the work that CPU does is based on the data in the RAM. The third one is the permanent storage. The only problem with RAM was that when you turn off the computer, it just goes away. Although RAM is extremely fast and you can quickly do lots of computations, but the downside of RAM is in case you turn the computer off, it just goes away. Okay, so basically the third component, which keeps the data permanently unless deleted, is called hard disk drive. There's an alternative today these days called solid state drive, which is extremely fast but is very costly. Right? So to store the data permanently, we have two things, two characteristics of the storage. One is how big it is and how fast it is. Right? The fourth component that has been largely ignored in the industry is network, meaning the how fast can we transmit the data from the network to your computer or from your computer to the network, right? So why does network matter? Imagine that you're trying to store huge data and you're trying to load a lot of data in the RAM, because RAM is small in the size, though it's fast, but it's very small. Let's say usually laptops come with 8 GB RAM or 4 GB RAM, and the servers generally have like 64 GB RAM or 32 GB RAM, and this is very small as compared to disk drive. Hard disk drives are generally of the size of uh, 1 TB, and solid state drives are generally of the size of 256 GBs. right? So you can see that hard disk drive or solid state drive are bigger in the size than RAM, but they keep the data permanently, and they are slower as compared to the RAM. Now, when you are having huge data, you will first try to stuff it in the RAM. If RAM is insufficient, you put it in the hard disk. And if hard disk is also insufficient, you put it somewhere else in network. And that's where the network becomes important, right? Most of the programs usually read the data from the network and get the work done. Now, when we deal with big data, at least one of these components becomes such a big bottleneck that you would require multiple such computers to get your work done. When we deal with big data, at least there will be one such big bottleneck that you cannot overcome by upgrading your system. And therefore, you would require multiple computers and hence distributed computing and hence big data processing. Now, question to all of you is this. Question to all of you is that which of these components impact the speed of computing? Yes, CPU, memory size, memory read speed, disk speed, disk read speed or write speed, disk size and network speed, or all of the above. That's right, it is all of the above. All right. Okay, a question from Chaitanya is, can you please elaborate on network speed? So if you have an application, the chances are, let's say, this application is reading data from a database or from another hard disk in the network, then the application is going to take time if the network is slow. Therefore, in the, in the applications today, the network speed might impact the overall computing. All right? Did it make sense to you, Chaitanya? Wonderful. Great. Now, you might question that when the big data is such a big problem and we require so many computers to deal with it, then why do we really need big data? Why can't we just live with the small data? Just delete the old data, keep the new data. What's the point of handling the huge data? What is the advantage of handling such a huge data, processing such a huge data? What if we just delete the old data and live happily with the new data, right? Yes, thank you, Anurag and Jiangi. So yes, there are many such cases. There are many use cases of huge data. The bigger the data, better are your predictions. It's like saying that more the experience, better are the outcomes, right? So imagine that we have, let's say, a website such as e-commerce, in which you need to give recommendations to users, right? If this website has huge data or the history of lots of users, then the website will be able to give better results. Otherwise, you might need to manually create the recommendations. All right. Since I am from the Amazon team, this page is very important to me because this page is the mobile edition is something that I built at Amazon. So here you will be amazed to know how much profit did recommendation drive to Amazon in the beginning. It was more than 20%. in the revenue just because of recommendations. So the recommendation is an amazing thing. Recommendation improves your revenue. If the more accurate they are, the more trust the user builds on you, user develops on you, right? And so suddenly, instead of you pestering the user by your advertising, right? You suddenly become a place where user can trust and discover new things, and that's where the recommendations play such a humongous role. I have built recommendation in past at InMobi. There we were churning around 200 terabyte data in order to come up with the recommendations. All right. So basically, recommendation was one such use case which became very popular amongst big data engineers. Though there are humongous, humongous use cases of big data. All right. So recommendations has a great history, and recommendation is something that is very much there everywhere. Now, if those who know about Netflix, probably everybody would be knowing about Netflix. So Netflix launched a challenge on recommendation of movies that became very popular because it has $1 million prize money. Afterwards, the same contest became the foundation stone for Kaggle, and a lot of such similar competitions have been organized on Kaggle since then, right? So basically, the recommendation engine, or there is another term for recommendations. Anybody wants to say? What is the alternative term that we use for recommendations? Yes? Perfect. Thank you, Smita. It's called collaborative filtering. Thank you, Venkat and Naveen, for review and suggestions. So yes, it's called, technically, recommendations are called collaborative filtering. Okay, so if you see the word collaborative filtering, don't freak out. It's essentially saying recommendations in technical terms. Now, a question from Tubatra is that how does ML modeling compare with this statistical modeling, since data is scarce there? So, okay, if the data is scarce, whether you use statistical modeling or ML modeling, the answer is going to be really, really biased and very, very specific, very, um, not insightful. Okay, but when the data is bigger, the right. Okay, so question is so in traditional statistical modeling, generally the data scientists would look at the data and would come up with all kinds of insights. But in case of ML modeling, we just feed the data to the models and let the models come up with insights. And that's a very thin line, hairline difference between traditional statistical modeling and ML modeling, because in ML modeling also you use various statistical techniques. If you are attending our machine learning course in morning, you will know the difference. You will know that in ML modeling also, we learn a lot about statistics. Okay, was I able to answer your question? All right, great set of questions. Keep the questions coming. Now, the next question is that this looks really complex, that you have user ID, you have like these recommendations, they are like magic. Okay, it's like magic, but it's actually very simple. If you look at the actual recommendation generation, it's as simple as this. You take the user ID, you prepare 3 columnar data set. I'm just taking a very simplistic case. So the important part is the one that I want to demonstrate here is that the core part of recommendation is already there. You can just feed the data and you can get the results using the libraries like MLlib. Now you may wonder, like, what are then data scientists doing? The data scientist's main time goes in cleaning the data and preparing this kind of table. This kind of 3-column data in which say user ID, product ID, and the rating. Now, figuring these 3 columns is what takes the time from data engineers and data scientists both, right? Feeding to MLlab and getting the results is something that is so straightforward and simple. In my experience, in my personal experience, more than 90% of the time goes in data cleaning and data processing. Remaining 10% time goes into feeding it to the algorithm and coming up with better answers. All right. So you can see clearly that here, the main challenge would remain that this one, preparing this data, and once we got the recommendation, showing it to the user is another task. All right. A question from Chaitanya is, I can only see only some recommendation if we select one item. So why a sum like large data is processed? Mhm. Feel free to rewrite your question. Probably that'll make it clear. Okay. Okay, a question from Apoorv is, can you please touch upon the terms like data analyst, data engineer, and data scientist? Can I take this? I have a proper slides ready and proper description of that in detail. I would like to take it towards the end. Just remind me if I forget. All right. Okay. All right. So sometimes we basically, Chaitanya, would you like to rephrase? Okay, as you said, you had processed almost 200 GB, actually 200 terabyte. Okay, data per one recommendation in Amazon, as we could see some items in recommendation if we select one. So I did that for InMobi, and there we had raw data about the users, right? So we basically first cleaned that 200 terabyte data, and then we fed that to that algorithm. Algorithm generated the model is like mind, like brain, and then using that model we generated the recommendations for all the users. We generated the recommendations for all the users. If a user does not have a history, then we generated the recommendation based on the product they are seeing right now, right? That's called product to product recommendation. And in case there is no history or we don't know what product the user is seeing right now, in that case, we basically took an average and created a curated list of popular items in their geography. All right. So even if you see one recommendation, that means maybe for you, the only suggestion is one recommendation, right? But if you have if you have many more if you have many more users, millions of users, so for all of them there'll be some recommendation. Okay, there will be some recommendation. I hope I was able to answer your question. So great. Thank you, Jatanya. Now second question is, second example of A/B testing in e-commerce is that it is called A/B testing, right? In e-commerce, the second example I want to take it is A/B testing. What is A/B testing? A/B testing comes from medical background, whereby, okay, so A/B testing comes from medical background, and in medical background we have, whenever there's a new drug, we would like to test it on the users, right? Once we have tested on animals, when we are completely comfortable, in case of in the pharmacological testing, what happens is the new drug is given to the patients. And so basically we compare something called pacifier, meaning it's nothing but just water. So we give some of the patients the simply water and some of the patients the actual medicine. And then we compare the results, compare the outcome, whether the medicine works or not. This is something done as part of the drug testing or pharmacological testing. Same thing we apply in e-commerce also. In in e-commerce, in e-commerce, this one is so prevalent in case of Amazon because Amazon has a lot of users and a lot of data. And since I am from the same team whereby the detail page is there from which you do buy now, that's something that we built. Now on that page you have, imagine that some of the users are saying, hey, let's have the red header. Others are saying that let's have green header. So instead of listening to one or the another, what you do is you build both the variations, right? You build both the variations A and B. You show variation A to 50% visitors and you show the variation B to remaining 50% visitors, right? And then you observe which one is giving better conversion. Right? Here you can see that variation A is giving 23% conversions while variation B is giving us 11% conversions. So which one do you think you should choose? Which color do you choose? Yes, based on this data. Yes, we should choose A, that is red. Perfect. So basically now you can see that the data speaks so clearly, right? Data speaks so clearly that there is no ambiguity. Whether red is nice or not, it doesn't matter because the conversions are coming from the red one. All right, you have to listen to the data. And that was something that we learned at Amazon also, that listen to the data, and instead of being confused about what is competitor doing, what our employee is doing, what our management is saying, instead of that, we focus on user behavior, we focus on the user, uh, what is it that users are comfortable with, right? So what we do at Amazon, good question, Kiran. So at Amazon, every component that you see on the screen is going under multiple variations. I'll just show you what page I'm talking about. So if you take a look at, say, Amazon, right? All right, it is going to have some of my purchase history, but that's okay. So imagine this here, right? Even this page, every section of this is going to be different for all of you. If you open it and compare it, there'll be some variations in at least one features, like should we display it like this or some other one? Should be green or yellow? The color of this box, the pre-order one, we have chosen based on the historical behavior of users, right? So here, if you, let's say, you see by now, this color has been chosen based on the data. Even these variations, the way we are displaying image here, this has been chosen based on the historical data. So all of these components are under A/B testing. You can take a look at this. Amazon, I'll just if I basically just copy this, the chances are I'm going to get different look and feel, at least at some of the components. All right. Okay, looks like the default selected image is different. You see here, the multiple objects are not there. You see, the multiple objects are not there. Here, multiple icons are there. Okay, so almost every time the it's going through all kinds of testing. No, this one is, there's no difference here. Let me see if I can spot more difference. Looks like they have not put a A/B testing over it yet. Okay, maybe we can't spot it now, but there'll be variations in various aspects. Okay, probably this is Alexa component product, which is close to the different teams. I could probably use some other company which is not that popular. Okay, so if we have something like this, right? I'm just trying to see if we can spot some differences, because most of the time, most of these things, the way we display reviews, the way we display questions, we had done a lot of A/B testing over there, whether to display the badge like this or in some other way, should we display it or not, and so on. So we basically do a lot of experimentation when it comes to the when it comes to improving the website or any other way. Let me just see, spot the differences. Do you spot the differences? Okay, I can't spot much. All right, looks like they're not running A/B testing much these days. Probably they have matured it. And all right, I can't spot the difference right now, but say you try to open it onto two different computers, take a look, because I know that for most of the time we are running the A/B testing. In case of Amazon, there are at least 100 A/B testing cases that are running on Amazon's detail page. All right. Right? That was the answer to Kiran's questions. So answer is yes. Question from Tubatra is there any, could you ask the question using Q&A window so that I can just focus there? Asmita and Tubatra, and yeah. A question from Ani Daniel is that, should I use MapReduce or Spark for data caching framework? Could you detail it out on our forum? I would love to answer it in detail, because the answer is not that straightforward. The quick answer, quick knee-jerk reaction would be yes. Anything that can be done with MapReduce can be done with the Spark. Therefore, you should be looking at Spark. All right, that is my quick answer. All right, but I can give you exact strategy whether to use Spark or any other technique if you come over to the forum and answer. All right, so on the website you will notice that there is something called forum. If you go to CloudxLab here, right? So on CloudxLab we have here, these are the courses. Then you basically have free tutorials, and then you have resources. You can click on forum here. Okay. So the forum has a lot of discussions. So you can come over and ask questions on the forum. Okay, great. Thank you, Ani. Question from Aram Devan is that, will A/B testing be visible if you hit the website from same IP? It all depends. In case of Amazon, we were tracking it based on the cookie that we set, but not based on the IP address, right? Otherwise, if there is a college and there is they're all behind the same firewall, they'll all have the same IP, and therefore there won't be any A/B testing. Good question. Question from Asmita is that, so basically this means that of suppose 76% are you buying the product, if buy button is red, then 24% choosing the green color button. Yes, we will keep it red in that case. Okay, the concept is right. And those who are wondering, it's a very important question. Generally, we do not launch a new product. We do not launch a new product on 100% users or 50% users. The way we do, usually the way we do the testing, the way we do the testing is, the way we do the testing is based on first we show it to 0.5% users, then 1% if it's doing well. So we divide the revenue numbers by the total percentage that we are giving it, and accordingly we compare. Okay, so instead of spoiling the experience for so many users. We spoil the experience for some of the users, like 0.5% for some time, and then observe that did it do well during that period of time, or did it do bad? Based on that, we dial it up or dial it down. Dial up means increase the percentage, and then we keep on increasing the percentage till we hit 100%. Okay, and once we hit 100% about new feature, then we remove the A/B testing from that particular feature, right? Because we have stabilized and we have proved that the new interface is perfectly fine. There's no need of the old interface. Okay. A question from Tubatra is there any other factor affecting the visitor rather than the variations that you have applied on different kind of users? There are many things out there. Some of the things are related to the flow of the users, okay? And so on. So there are many things out there that affect the user's behavior, and you got to observe every part. And that's why the engineers, data scientists, they all look at the user flow, right? A question from Priyanka is that how do you target the 0.5% user? So basically, when the request is coming, when the request is coming from the user, what we do is we basically do a coin toss, right? And in 0.5% cases, what we do is we basically put a particular flag that, hey, this belongs to this particular A/B test case, right? And in our code, we say that if the A/B test case is this particular, then show this variation, otherwise show that variation, right? That's how the most of the A/B testing frameworks work. If you come over to the forum, I would love to answer it in more detail, because designing a framework for few users, I mean, designing a framework like A/B testing is really complex and requires a lot of work over there, right? So I would love to answer it in details, and here we go. Now, the things like A/B testing are possible because Amazon is able to handle so many requests and is able to handle the complexity of showing the A/B, showing the various variations. Now, that A/B testing, other than A/B testing, something I would like to add here, right? I mean, this is based on my recent understanding of various e-commerce companies when I discussed with them. These days, machine learning or big data is used in pricing, demand forecast, the 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 acquisition forecast, the fraud detection with respect to the buyers, meaning lots of buyers are basically sending the items back based on the user's behavior of the past. We basically figure out that, okay, these are the users which look like fraud based on their purchase history, right? So and along with that, there are some vendors who are fraudulent. Basically, we use the data to detect the fraud vendors, fraud buyers, and the pricing strategies, and prediction of prices, prediction of demand, prediction of traffic, and so on. Even the prediction of whether the user is going to purchase or not is based on the data. All right, so that's basically the A/B testing. Not A/B testing, that's basically the use of big data in case of e-commerce. All right, now the a question from Kiran is, can you please detail the price detection? It's not price detection, price prediction. Okay, so if a particular item is in high demand, and we see that okay, looks like giving less discount on this product is completely okay. All right, so there are multiple strategies over there in case of price prediction, and therefore the there's a huge use case of data in predicting the price. All right, in predicting the price of a component. of a product. If we decrease the price, the sales will go down and the total revenue will drop down. If we decrease the price, then we'll make more losses. Therefore, predicting the price based on the demand and user behavior is something that is very crucial in e-commerce. All right, and that's done based on the historical behavior. So the price is not generally per user, but the user behavior counts when we come up with the price of a product. All right, so going ahead with, and again, we don't do A/B analytics on pricing. Otherwise, people would not trust the website. Okay, so if we are doing A/B analytics, A/B testing, or sometimes we call it control versus treatment. Okay, control is something that was there as such, and treatment is the new feature that we are applying. So we don't do control versus treatment or A/B testing on the price ever. Okay. Next question is that, are there any other industries that can take advantage of huge data processing? The one is government. They use the big data for fraud detection, cybersecurity, welfare, and justice. Okay. The second one is telecom. Telecom is, this one I have experienced like a couple of use cases, and I'm amazed at every time the use case comes along. So telecommunication is some industry which is very, very IT savvy, in the sense that they have been the largest consumer of the data warehousing. If you meet some people from telecom, you will know that there have been they were like senior DBA doing humongous data churning. But today, telecom is the first one to move to big data because their data was hitting the upper limit of handling, upper limit of the data that could be handled by the relational databases. Okay, so whether it's basically preventing the customer churn, meaning so that customer do not leave, coming up with the strategies or figuring out what is it that causing customers leave, that's like crucial for any telecom. Second is network performance optimization based on prediction of the load in various areas in the city. They need to come up with strategies so that they can do the network performance optimization. Next is calling data record analysis based on the user's calling behavior. A lot of things could be done. The fourth one is analyzing network to predict failure. Now, this is something interesting. So somebody actually came up last year saying that, hey, we are facing a problem in the network, and what we want to do is every time our equipment fails, we should know in advance at least 5 minutes before. And because there's a different pattern of the information from each of the equipment, therefore we can predict the network failure before it happens. So given the past history of the failures, we basically picked up the history, and then and based on that, we trained our model. And first of all, we cleaned the data using big data platform and prepare the data to be processed by the machine learning model, right? The one important use case which is not mentioned here that came in 2014, right? Well, somebody approached me, and what they were doing is they were basically maintaining the configurations of every tower in XML files. Now, as and when they're changing the configuration of various equipments in the tower, they were basically saving the entire change. They were basically saving the configuration every time. So there were many copies of the configuration. Now, what they wanted was to understand which change in the configuration has led to better performance, right? For that, they wanted to do the big data processing to be able to do performance optimization based on the configuration changes. This problem sounded to me really simple, but when I looked at their XML file was around 100 gigabyte. And that's when I realized that that cannot be processed by usual systems, because usual systems will not be able to load 100 gigabytes into the memory and solve it, right? So there are many use cases of big data in case of telecom. We'll continue from healthcare after the break. Let's take a break for 10 minutes. All right, so let's get started. All right, there are a couple of questions before we move ahead. One of the questions is, could somebody explain A/B testing in short, please? Basically, trying various versions of the features for the users and figuring out which A or B is better. Okay, comparing the two versions of the same feature. A is being shown to some people and B is shown to some people. That is basically testing one user interface against another. That's called A/B testing. All right, as opposed to the normal common sense, here we design two interface, A as well as B, and we show it to the users and figure out which one is leading to better experience based on conversions. All right, if you ask a survey, in a survey you may not get that great results, but if you see that if you basically see their behavior, that'll be better. For example, in this webinar, if we basically rely only on your feedback, that is important to get the feedback, but also we need to come up with better mechanisms to understand the user behavior, like how many of participants are staying till end, how many of them are leaving in midway, and so on, right? So that's basically figuring out figuring out whether some a feature A is better or B is better based on the concrete results. All right, so that's about A/B testing. Now there's a couple of questions. Let me answer those. A question from Jiangi is that if you run 100 or 1,000 tests, you may get significant results due to type 1 error. How do you usually handle that? All right, good question, but you also need to see the majority in these tests, right? If you are running in 100, uh, if you are having 100 test case, is the result significant in majority of cases or in minority? Similarly, there is something called hypothesis testing. There are multiple ways of doing hypothesis testing. So something is, whenever we come up with a hypothesis that, hey, there is something wrong, and we come up with a new feature or a new user interface or a new drug or a new case, then we basically observe whether the hypothesis that this new user interface will work is right or wrong. Okay, based on the data, right? So there are I can go into more details, but I would love to answer it over the forum because this would require some amount of detailing from my side. All right, it's a classic, the hypothesis testing kind of scenario, and in that case, you will know how to you will understand that proving that something is right or wrong based on the data requires a bit of analysis. All right. A question from Ashutosh is how big data can help in communication. As I said, that most of the telecoms have humongous data, and if they are able to perform various kinds of analysis on their data, they will be able to do many magic, such as they'll be able to figure out why customers are leaving them and hence stop the customers from leaving or prevent the customers from leaving. Second is network performance optimization, in the sense that they will be able to optimize the network performance based on the historical user experiences. Third is the calling record data analysis. Based on the users calling records, they can do a lot of magic out there. Fourth one is analyzing network to predict failure. That's another example in case of telecom. All right. The next one is the healthcare. A question from Chaitanya is routing performance also involves big data telecom analysis. Yes, the reason is that even the routing in case of telecom is a humongous data. Therefore, that also involves big data analysis. Earlier when they had small data, when there was not too much of history, then they were happy with their normal SQL and kind of analysis. But today, when the data has grown bigger, the any kind of analysis requires a big data platform. All right. So the next thing is the healthcare and life sciences. In healthcare and life sciences, you have health information exchange. Since in healthcare and life sciences, almost everything is big data. Therefore, even things like information exchange or gene sequencing or healthcare improvement or drug safety, all of those are basically the big data use cases. Okay. So drug safety again is kind of churning humongous data, comparing drugs and performances and so on. Similarly, healthcare improvement, going through the user's past data and observing are there any improvements. Then the gene sequencing, basically figuring out that which kind of gene is causing what kind of behavior, as well as what kind of gene mutation is causing cancer, what kind of gene mutation is causing this, and so on. So basically, almost every problem related to healthcare is a big data problem. All right. So now we talked about why big data is important, why big data is a problem, what is not a big data, what is a big data, and so on. Now, the next thing we need to understand is how do we generally solve the big data problems. Okay. So there are two kinds. If you have problems like a question from Manish is how they were getting addressed before big data. So before big data platform, they had their own mechanisms. Most of them were actually ignoring lots of historical data in order to come up with the new insights. They were basically doing sampling, only considering latest data, or most of them did not have too much of data. But today they have access to a lot of data, a lot of human behavior. Therefore, now they're able to utilize the big data platform, right? So I hope that answers your question. Question from Kiran is, which companies are using big data in medical? I have met many companies, but I don't have an exhaustive list. Okay. So whether it's insurance companies in medical or the medical companies itself, almost everybody is either building their big data platform or already using the big data platform in order to solve various problems, right? So one of my friends who basically is a CIO at a company called Mad Mad Genome, Medical Genome, they are using big data big time. Another friend that who has basically I've been talking to, I mean, I'm talking about the real evidences, which I know personally. A company called Medic Life, they're also utilizing humongous data now. I have placed one of my learners there, and I mean, these are something just two instances in last couple of months, and I mean, in my opinion, almost every large organization today is using big data in one way or another, or utilizing big data platforms in one way or another. Good question, Kiran. Moving ahead, if your data is related to lots of requests coming from the user and you need to store that data, you will generally go for things like Cassandra or MongoDB. These are called NoSQL data stores. They're extremely fast for storing humongous data. Now, you would basically, if you want to build an analytics platform, in that case, you will generally go with a combination of Hadoop and Spark, right? Although if you are basically not having uh, access to if you are not interested in building your own platform, you can use the services from Google and AWS. But lots of enterprises avoid it because they don't want to be logged in. They don't want to have a vendor lock-in with Google or AWS. Therefore, the most common choice is Hadoop and Spark, either on their infrastructure in their private cloud or on the Google or AWS or Microsoft or IBM. Okay, or even AliExpress has come with the cloud, so you can take that and install it there, right? Now, they basically use either of them. The most common platform for analytics is Hadoop combined with Spark. Most common one for handling the velocity is Cassandra or MongoDB. These are called NoSQLs. When I say velocity in terms of lots of data coming from the user and we are supposed to keep it, in that case, people use Cassandra, MongoDB, or Kafka. And also the Spark has also come up with something called Spark streaming, but that's not really same as this. Okay, now most of the analytics or machine learning pipelines can be done using a combination of Hadoop and Spark. Okay, again, a question from Sudarshan is, can you please give an example of how to when to use Cassandra and MongoDB? All right, let me explain what is Cassandra and what is MongoDB. Cassandra or MongoDB is called NoSQLs, right? What is NoSQL? When you are having a normal relational database, instead of only select queries, you are also doing insert or update queries, correct? When insert and update queries are too huge and there are too many, your normal database cannot handle, meaning when the users are inserting or uploading or you're creating lots and lots of records per second, in that case, the Cassandra or MongoDB are used instead of relational database because relational database cannot handle those many requests. And therefore Cassandra and MongoDB is great when there are lots of write requests, write as in WRITE, while Hadoop and Spark are great when the data, it's mostly for data processing, such as when the data is relatively static. In that case, Hadoop and Spark are great. But along with Cassandra and MongoDB, there's one component from Hadoop called HBase and HDFS that is also used for lots of writes from the users. Okay. Yes, Asmita, that's right. That's basically MongoDB is handling insert update of non-relational data, as in semi-relational, you can say. Okay. Question from Chaitanya is, Cassandra and MongoDB are for velocity and also for volume. That's right, but for volume, I think the Hadoop's HDFS is better. Okay. Question from Jiangi is, considering your IT cost, staffing, etc. A question from Jiangi is using a Spark on owned infrastructure much cheaper than AWS Google? After a size, let's say if your total infrastructure is going beyond, say, 20 nodes, generally people found it setting up in their own private infrastructure is cheaper than AWS and Google. All right. So that's what the statistics given to me, but I've seen lots of people even using like 100 servers. Okay. Today, the virtualization has made it possible that you can create your own virtual environment and have your own task force to handle your infrastructure. All right. So that's Jiangi's question. Let me answer more question. Okay. That's right. No schema database is called NoSQL, right? Question from Valley is, what do you think about statistical tools in big data? So Spark provides you all the statistical tool and they are needed because what happens is when you come to distributed computing, your mechanisms of handling humongous data change completely. And therefore the underlying libraries are required to be changed, and hence Spark had to come up with all kinds of libraries. I'm going to talk about it soon. Okay, so yes, statistics tool are very necessary when we deal with humongous data or any kind of analytics. All right. A question from Mithul is, can we say that Hadoop and Spark are related with data processing, whereas Cassandra and MongoDBs are more concerned on high volume or high velocity storage? I'll just want to add one more word here, high volume or high velocity data storage. Yes. Question from Annie Daniel is that if I got to do caching work, should we go with MapReduce or Spark? Caching work in what sense, Annie? I would love to understand what does it mean by caching work that you're trying to do. Okay, so if you are trying to do, let's say, caching of the data in the memory, then probably Spark is better. And let me be very, very straightforward to you. Most of the work almost everything that can be done with MapReduce can be done with Spark and much more. So the simple answer would be whether you are trying to do caching or something else, I think you should go with Spark. All right. MapReduce people these days are not using that much, only in the legacy examples where there is already MapReduce, only there people are using MapReduce. All right. A question from Yang is, do you have any comments on Microsoft Databricks Spark comparing to the open source Spark? So basically it's the same thing, just that the user interface is much better, but learning whatever we have today in this course will apply there also. Okay, it's the same thing whether being run on the Windows or anywhere, because Spark is written in Scala, which is nothing but gets compiled to run on Java, and therefore Spark can run in the same way on Windows as well as Linux. Therefore, theoretically, there will not be any difference. Okay, the only difference will arise because of open source and non-open source. So when it comes to non-open source, they have come up with a very nice interface that you can use. All right. A question from Priyanka is, can you tell what you mean by statistical methods in Spark? So let's say you want to do hypothesis testing on using Spark, right? That you can do. With statistical methods like finding the standard deviation, finding the outliers, and so on. All of that can be done very well with Spark statistical libraries. Okay. A question from Soumya is, can you give real life example of something stored using Cassandra to understand the difference of that versus something stored using Hadoop? All right. So imagine this. I mean, I'll tell you from my personal experience where we were using Cassandra. So at NOB, after we have built the recommendation engine, the next project I was doing was building a tool so that the game developers could give the rewards or provide some kind of points to various game players. So what we had done was we have designed a tool for game developers, right? And we basically had stitched it into their games, right? So what they would do is they'll observe the analytics in real time based on the users, and then they'll give quickly the rewards. So there we were using Cassandra to store the current user's behavior. A lots of data was coming from the users continuously in a structured form that this user is doing this, is stuck at this particular label, and this game developers will take a look at it and then do a quick churning of that data and send them the rewards that all the users who are stuck at this particular label and have tried these many times should get extra marks. So that kind of real-time rewards was something that we built using Cassandra because we were expecting lots and lots of users to use it, lots of developers and lots of games to upload the data. Therefore, in that case, we were using Cassandra as opposed to say HDFS, because HDFS had latency, meaning every write takes a lot of time. Therefore, we avoided that. We did not use Hive. We did not use HBase or other things because of installing the Hadoop. We were not having Hadoop at that point of time. We were just using Cassandra to do rest of the analytics. Okay, so when you are having a lot of updates from the users, you prefer to put them in some NoSQL database. All right. A question from Sakar is, are you going to discuss about Hortonworks data platform in this course? Is it relevant to big data implementation. I'm going to talk about it briefly. So it's the same Hadoop being packaged by Hortonworks and Cloudera. Now both the companies are merged into one, and others also. So on our CloudxLab, we have Hortonworks data platform along with we had already merged Hortonworks and Cloudera on our CloudxLab, right? They have done it now. They have merged the companies now, but that's the way we had done earlier on CloudxLab. So yes, we are going to use both the platforms as part of the CloudxLab. A question from Asutosh is, for Spark, we go for Scala or Python. The thumb rule is we go for Scala because most of the components are in Scala. And Python, everything which we are learning, we are going to learn in Scala will be applicable in Python. So we found that it's safe to go with Scala because most of the data engineers are expected to know Scala as opposed to Python. While most of the data scientists or machine learning scientists are supposed to know Python. But trust me, if you know Scala, you know Python. All right? It's not a big deal because Scala is nothing but Java written in a style of Python. Okay? Great questions. Keep the questions coming. That's the way to learn. You would trust me on this. Only the things you will remember is not what I told, but what you asked. Okay? So pay attention to your questions. Ask more questions. All right. Question from Abhishek is, what are some good stacks that help visualize the insights we make out of big data? So big data platform do not provide any visualization because visualizing 200 terabyte data does not make any sense. It's only once using big data platform, we basically create meaningful, smaller data set that you can visualize using your existing tool. Whether you are using BERT, B-I-R-T, BERT, or using Tableau or using Excel to visualize the data, you can basically use the same tools. You can connect your Excel to load the data from big data platform. One of the components that we will talk about is Hive. Other component that we'll talk about, Spark. These components basically help you visualize the data from basically using your existing visualization tool. You can connect to Hive, Spark SQL, and present the data there. In the back end, it'll be the big data processing, but for the end user, it'll be nice graphs and charts. All right. A question from Priyanka is knowledge of Java must for working with Hadoop and Spark? Not really. For Hadoop, Hadoop does not really require a programming language per se. It is important to understand various components. In case of Hadoop, only a little bit of SQL is required. While in case of Spark, it's up to you whether you want to use Spark SQL, Spark R, Scala with Spark, or Java with Spark, or Python with Spark. Spark provides the libraries in almost every programming language. So in simple words, Java is not really must for either Spark or Hadoop. A question from Asmita is, so Spark is basically another programming language like R, which has many libraries and can perform ML modeling. So Spark did a very smart thing. Instead of creating a new language, they relied upon existing language. They only created a library which internally distributes the work on top of Hadoop. Okay, so basically they provide an interface in R, they provide an interface in Scala, they provide an interface in Java, and so on. So basically they are like a framework which internally divides your work onto multiple computers. So whether you can talk to this framework using R, Python, Scala, Java, or SQL. All right, though Spark is under the hood written in Scala, but you can talk to it in almost like 5-6 languages. All right. Bear with me. Let me just finish the questions. I'm sure that these questions are useful to you. They are basically giving you an idea about what's going on, right? A question is, does big data or big data tools use help in real estate, land record, or residential commercial property registration system records? So again, it depends on how big your data is. If your data is beyond, say, 10-15 gigabytes, then you will have to go for big data. If your data is within like a couple of gigabytes, then probably would not require. There you will need multitude of technologies to solve that problem. The big data tools alone will not be of help. All right. All right, you will need a way of converting the scanned papers into something meaningful. There are quite a few libraries for that. And then using that information, you will need a way to create a database system, create a database whereby you will insert this data and create a structured data out of this unstructured data. For that, in case your data is humongous, in case your images or the land scanned records are beyond 15 gigabytes or 20 gigabytes, then chances are that you will require a big data processing environment. Great questions. Keep the questions coming. These questions are going to be very helpful for all of you. And this is the feedback I have. I'm talking about the feedbacks given by the users that, hey, we got a job thanks to this open discussion. It so happens that the interviewers basically ask the same questions, okay, which the other persons are asking. All right, so pay attention. This is what helps everyone, and this is what builds the confidence in the technology, in yourself about these frameworks. Now, question from anonymous attendee is Cassandra also a document-oriented database? Cassandra is more like a tabular database, and not like MongoDB, which is document-oriented database, right? What is document? Document is nothing but a complex key value pairs. So most of the document like a Microsoft Office, Microsoft Doc, or something, they can be represented as a complex structure of key value pairs and in a hierarchical way. And therefore, those kind of documents are better stored in MongoDB or CouchDB or similar NoSQL databases. So Cassandra is a kind of a tabular, like flat file, like flat table kind of environment where you have columns, column family, and tables, and you have you keep on setting the values there. All right. Question from Sudarshan is, can we use Microsoft BI tools for analytics and visualization? Yes, of course, you can use Microsoft BI, Tableau, BIRT, BERT, Crystal Reports, Excel, anything to talk to big data platforms such as Hive or Spark SQL to represent the data to the end user in the forms of graphs and charts or summaries and so on. All right, wonderful questions. And the question from Abhishek is, what are some good stacks that help visualize? Okay, this I've answered already. Wonderful. So that was a good discussion on various aspects of big data. Moving ahead, so the first question that comes is, what is Hadoop? We hear a lot about Hadoop. What does it mean by Hadoop? So Hadoop is something that was created by Doug Cutting, who is working at Yahoo, and they were, in his personal time, he was trying to build a search engine with the name Nudge. So when he was trying to build search engine, he realized that the way search engines work is they go to the websites, right? They go to the website and they download the data from the website. This is called crawling. Then when they download the website, when they download a website, they also scan through the website to find more links, and then they download those links, and again they find more links, and then they download those links, and the chain keeps on going. So for that kind of storage, for that kind of corpus of text, that kind of the data from various websites, we need a humongous storage. When we search at Google, what it does is it basically looks into its local index. It doesn't go to the individual website and search there. Instead, it basically looks up in its own index, right? And that's where the Nuts search engine was trying to do. They were trying to build their search engine and they were stuck. Why? Because they had to build a storage to store the World Wide Web, correct? Because when you are building a search engine of www size, you need to have humongous storage. You need to be able to store petabyte data. That's where they were stuck, right? He was joined by Mike Cafarella, and luckily for them, Google released the three papers called Google File System, Google MapReduce, and Google Bigtable. So instead of continuing with the nut search engine, what they did was they first implemented these 3 papers, and that's what became Hadoop. Hadoop initially was based on these 3 components. Google File System became HDFS, Hadoop File System, Hadoop Distributed File System, and Google MapReduce became Hadoop MapReduce. Google Bigtable became HBase, right? These 3 components were the initial one at Hadoop, and that's where the Hadoop got started. Hadoop was an open source project, and under the Apache license. Even today, Hadoop is open source and under Apache license, which means that you can use Hadoop in your personal, professional, or educational project without any worry. So anything that is under Apache license is open and liberal, and you can use it in all kinds of environment. That's the great thing about open source license of the Apache open source license. So basically, the Hadoop was essentially these 3 components, but later on it became popular, it became powerful and well supported, and hence there were lots and lots of components were added to Hadoop, and it became a framework to handle big data. Hadoop was for distributed, scalable, and reliable computing. Hadoop became any component that wants to register themselves under the umbrella of Hadoop, because there were more and more components that were coming up that could, one way or another, support Hadoop. Therefore, Hadoop guys made a rule that anybody who wants to come under Hadoop umbrella, they need to be distributed, scalable, and reliable. What does it mean by distributed? Distributed means this software, all the software under Hadoop umbrella is distributed, meaning they run on multitude of computers simultaneously. Scalable, if you have 5 computers today, then also your software works fine, and you add a couple of more computers tomorrow, then also your software works fine. You don't need to reinstall everything. Similarly, if you want to remove a couple of computers, you should be able to scale. So whether you want to scale up, as in increase the capacity, or scale down, meaning decrease the capacity, the software should not have a problem. All the components under the Hadoop umbrella have these 3 properties. Now, the third one is reliable. What does it mean by reliable? In case some of the machines go down, some of the computers go down that are part of this cluster, part of this distributed network cluster, even if some of the components go down, it should not matter. It should be able to handle the unreliable machines. That's called reliable computing. All right. Hadoop was written in Java, but that doesn't mean anything. Now you can interact with Hadoop using all kinds of programming. All right. Now, brief about distributions of Hadoop. There is something called Hortonworks HDP, Hortonworks Data Platform. That's from a company called Hortonworks. It provides the Apache Hadoop and Spark. It provides a tool, additional tool to normal Hadoop and Spark. It's called Ambari. It's for provisioning and workbench. Then there is a second component called Cloudera that provides Hadoop and Spark. And then that provides basically something called Cloudera Manager from. So basically these 2 companies were packaging additional component along with the basic ones. Here it was packaging Ambari, here it was packaging Cloudera Manager and Hue. And there was a company called MapReduce that also was shipping the same open source Hadoop. All right. And they were also having some more additional components. Okay, so Hadoop hosting in the cloud, if you are not interested in setting up your own Hadoop on your local machine or local network, you can either do it on Microsoft Azure. Microsoft Azure, basically there is a slightly different HDP called HD Insight. It's basically HDP that runs on Windows, and basically it provides something extension to .NET plus Java. If you are hosting, you can also use Amazon EC2. we have created a video. You can try, you will get the slides. You can all, I can also give you the link right now. Okay, and the YouTube video is available there. And basically, EC2 also provides a custom MapReduce, which can basically run the same code that Hadoop MapReduce will run. Okay. So the Amazon has not only provided a way of installing Hadoop on their cluster, but also provided the Hadoop related jobs on their platform. You can also install the same thing on Google Cloud Platform. All right. So let's get started with the components of Hadoop ecosystem. Okay. Do you have any question before that? Ani, I kind of forgot the Ani Daniel. I kind of forgot the context. How can I work on both? Do you mean work on both Hadoop and Spark? Basically, Spark can run on Hadoop, so that's not a problem. If you mean that, how can I work on both MongoDB and Cassandra? You would not require that. Okay. All right. Great. Moving ahead. So what you see here is the ecosystem of Hadoop. Okay, I'm going to walk you through this ecosystem. This ecosystem is quite important, and it's basically very much, you know, complete to do various kinds of data analysis tasks. A question from Chaitanya is, what's Hortonworks? Hortonworks is a company which basically supports Hadoop. They provide support around Hadoop in case you are a company which wants a Hadoop implementation in your organization and you don't want any unforeseen problems. In that case, you basically hire Hortonworks. Hortonworks or Cloudera, they support Hadoop. They provide services around Hadoop. All right. Great. Let's move ahead. A question from Chaitanya is, Amazon EC2 needs Hortonworks like SD inside? So yes, you can install the normal HDP called Hortonworks Data Platform on Amazon. This is where we have shown you this video. We have actually done it for our students. And they also provide a custom version. They have implemented the same thing on Amazon. This is highly customized, specific to Amazon. All right. Wonderful questions. So moving ahead, yes, Jay, you have raised your hand. Any questions? A question from Darren is, what's the difference between MapR DB? Does MapR provides a DB? MapR DB. Let me just take a look. So they have built a NoSQL performance engine, and it's basically probably it's kind of would be based on HBase. Wow. All right. This is, yeah. So MapR basically provided a NoSQL just like MongoDB or Cassandra, which can run on top of MapR platform. Okay. Probably this is similar to HBase or so on. Question from Asmita is, do we have Hortonworks installed on CloudxLab? Yes. So the way we have set up CloudxLab is we took Hortonworks, installed it, then we installed the extra components from Cloudera. So the way we did was, let me just visualize it for you. Okay. So first of all, we basically set up the everything using HDP, Hortonworks Data Platform. Then on top of it, we put the things from Cloudera, okay, whatever we could. And then on top of it, we put all the things related to deep learning and machine learning, such as Jupyter, NumPy, SciPy, scikit-learn, etc., so that our learner can mix and merge the technologies. And here, Cloudera, we took Hue and etc., right? So, and on top of it, we put the TensorFlow. It's not on top of it as such. We basically installed in parallel, you can say. This is essentially in parallel, okay? It's not really that without Cloudera, we can't install TensorFlow. Though these two are one top of another. These two are one top of another, while this and this, okay? These are one on top of another. And this are basically something like parallel, okay? And this is something like being installed. So if this is your computer, here, this is your computer, this is what we have provided, right? This is. So we installed, after setting up CloudxLab servers, we installed HTTP, then Cloudera. Parallelly, we installed machine learning tools and TensorFlow for deep learning, and so on. We are adding more and more. All right. So we keep on adding all the things that are required for any of the computation learning, and that's basically the idea. A question from Asmita is HDP is basically for hosting big data analytics stuff. HDP is basically a package that contains, the HDP is basically a software that you can download and install on your laptop as well. HDP is essentially that bunch of softwares combined together so that it can run all in tandem, okay? It's like software package, correct? So moving ahead, great set of questions. Keep the questions coming. Now, in the Hadoop ecosystem, one of the most powerful thing is Zookeeper. Zookeeper is the one that everybody depends upon. Zookeeper is a component that nobody talks about while everybody depends upon. For example, SDFS depends upon Zookeeper. Even non-Hadoop components, right? Non-Hadoop components such as Kafka and Spark, they all depend upon Zookeeper. HBase depends upon Zookeeper, Hive depends upon Zookeeper. Zookeeper is like the central, it's like a big central place where everybody goes and inform that, hey, I have these many services running, and so on. Almost everybody informs their status to Zookeeper. All right. Now the second component, so Zookeeper has nothing to do with Hadoop. It's a generalized service, and people use Zookeeper even in non-Hadoop environments. Okay, it's a very tiny, you can think of Zookeeper as very tiny database, which is really, really parallel, meaning this database is it's like a small tiny database that basically itself runs on multiple computers, and it can cater to thousands and thousands of users. Okay, so just that you don't store too much data here because it's not meant for keeping too much data. The design, the principles are such that for storing the coordination information that, hey, I'm running here, I'm running there, that kind of information is generally kept in Zookeeper. So you don't have to keep too much information or actual data in Zookeeper. All right, Zookeeper is for coordination between all these services. Now, the first component of Hadoop is Hadoop distributed file system. This one is an external component. Zookeeper is an external component, while Hadoop distributed file system is the first most important component of Hadoop ecosystem. I'll just devote a couple of minutes describing what it means by Hadoop file system. So Hadoop file system involves many computers. Hadoop file system do not run on single computer. You can run it, but it's not really useful. Hadoop file system is run on multitude of computers such that we can store data automatically on multitude of computers. The backup of one file is kept at another, and so on. And in order to handle really large file, Hadoop file system cuts the file into parts, and then those parts are moved around. So Hadoop file system basically provides a way to utilize the storages of multiple computers, and without you having to keep track of which file is where. Hadoop distributed file system keeps track of which file is where. Okay, so Hadoop distributed file system is for storing humongous data in the form of files and folders, right? Just like you have on your Windows C:. Similarly, in case of Hadoop, we have the Hadoop distributed file system. Instead of just going theoretical, let me just try to demonstrate to you what it means by Hadoop distributed file system. Okay, so when you are at CloudxLab, you can sign up with CloudxLab. It's free for a week, and even the monthly charges are very, very low, so it won't pinch you at all. And since we have to pay to Amazon, that's why we charge for CloudxLab access. Yes, Vali, you have a question? You have raised the hand. Jay, you have a question? You have raised the hand. You can ask the question using the chat, right? So this is how it looks like a file system. You see, this is a folder, this is a file. You can see this is another file, and so on. You can see, and I can just click on a file and see. So it's just like normal Windows file system, just that under the hood, this data is being divided or distributed on multiple computers. Okay. You can see it's just a normal file. Perfect. Right. Now let's take a look at CloudxLab various services before we move ahead with the Hadoop ecosystem. So you can see, all right, there is something. Okay. My courses, not my courses, let me say my lab. Okay. In my lab, you'll get the lab credentials, you'll get MySQL details, and you will also see IP mappings like this. Okay. And basically, because every private IP has a public name that we need to tell the user, that's why we have listed all the public IPs. Similarly, we have MySQL credentials using which you can log into MySQL. This is the command that we have. Now, next one is the lab credentials. These are the per user lab credentials that get created as soon as you sign up. So you can click on Ambari. Ambari is nothing but a way to visualize the whole network, a way to administer the network. You can add more hosts, you can add more computers to the network, and you can add more software to existing computers. So basically, Ambari is like a provisioning tool in case of Hadoop, right? Then we have Hue. Hue is from Cloudera. Hue lets you interact with every component. Ambari is generally used for administration, though Ambari has come up with its own visualization tools and other interactive tools. But Hue is the one that's generally used for interacting with various components. So if you want to create a folder in HDFS, you can use Hue. If you want to execute a query on Hive, you can use Hue, and so on, right? Ambari is for quickly visualizing what's going on. Here you can see this is HDFS, 3 data nodes have started, and so on. Understanding of these will happen during the course, like what does it mean by these services? And these are the various services running on the cluster. All right, we have Kafka, we have Zookeeper, we have so on, you can see. So basically all these services are running. If you want to add more components or more servers, you can just go to hosts and click on add new host. Okay, since I'm the admin, I'm able to do all of this. You may not be able to do all of this. All right, so using that, we can add more computers to the network and so on, right? The hue that you see is basically for interacting various components is quite useful when it comes to executing various things. All right, so coming back to it, here you have the Hadoop distributed file system, which is basically just like files and folders, and everybody stores the data in HDFS. The power of HDFS is that it stores the data using multiple computers, and in case some of the computers go down, even that the data is safe, it can recover automatically, it can scale automatically, it is very reliable. All right, that's Hadoop distributed file system in very simple words. We'll go into more details in the second chapter of the course. Now, the second component is Yarn. Yarn is like distributed operating system. It keeps track of which computer is busy and which computer is free. The way we have utilized multiple computers to store data using HDFS, in the same way, Yarn utilizes multiple computers, those same multiple computers, to execute the programs. Right? So Yarn is like operating system, HDFS is like your C colon, D colon, and on top of it, we have MapReduce. MapReduce is like a query engine whereby you can run your program. This MapReduce will talk to Yarn and get its work done on the Yarn. All right. So a question from Kiran is the data warehouses is implementation of HDFS? Data warehouses is an implementation of the entire ecosystem, right? Not only HDFS. Because in data warehousing, you don't do only the storage, but you also do data processing. A question from Mithul is, depending upon what parameter does Hadoop distributed file system breaks the data? Generally, the data breaking into blocks happens on a hard boundary, not based on any other parameter other than the size of the file. Okay, HDFS basically breaks the data based on the file size. These days, the file size is 128 megabyte. So if you have 1 gigabyte, it'll cut it down into eight parts and distribute those 8 parts onto the network, make the copy of each one so that if one computer goes down, there are other copies available of that data, right? So that's about HDFS. Now, this MapReduce is a compute engine. This is a very innovative concept called MapReduce, in which we basically give our logic in the form of 2 parts called map and reduce, and that one basically executes it in a way that the way we run the SQL query, right? So you can think of MapReduce as query executor, just that instead of writing SQL query, we are writing the code in Java or any other programming language. So MapReduce basically was the first way of distributing the computing. Later on, MapReduce was broken down into MapReduce 2 and Yarn basically was only for tracking and being able to execute anything on the cluster, right? So MapReduce basically asks Yarn to, hey, can you execute my work? MapReduce basically orders Yarn to execute maps and reduces onto the network, right? So MapReduce asks Yarn to do something, and Yarn basically also talks to HDFS, finds out which computer is having data, which is not having data. The computers which are having data, that's where it'll send the program to be executed. So that kind of mechanics is handled by Yarn. Now, similar to MapReduce, we have something called Spark. Spark is a direct competitor to MapReduce, and these days, because Spark had won the sorting benchmark against MapReduce, everybody has shifted to Spark. Spark provides far more flexibility, and I myself am a big fan of using Spark as opposed to MapReduce, because Spark is quicker, not only in terms of execution, but also in terms of the developer coding work. As in, you will notice that if I have to just show you how does the Spark looks like, you will find that to be far more useful. If you guys want, I can just quickly demonstrate what it means by Hadoop. Let me see if I could quickly show you. Okay, let me just log in into my account. This is called console. Those who are new to console, don't worry, because here when you type the password, nothing will be visible. Now here I've just logged in. Let me increase the font so that all can see. So here, this is where you execute the command. So you can use Hadoop fs command to talk to HDFS. You can use Hadoop jar command to talk to Hadoop MapReduce, right? Let me just see if, oh, I don't have right now the commands. Okay, so I have a lot of data here. Okay, okay, let me see if I could demonstrate to you how does okay, so how does the Hadoop examples work like? All right, I'm right now compiling my program. Don't get intimidated because this looks like just too much, but it's actually pretty simple. When you are doing it, it'll be simpler. So here I'm basically trying to compute the word count using my Java program. Since I had already done it earlier, there was the file was already there. So I'm just deleting the file. Okay, let me just show you. All right, this is how a typical Hadoop MapReduce job looks like. So right now what I'm doing is it's reading a file from the HDFS, computing the word count, and going to save in the outcome. This is how the MapReduce looks like. Okay, so you can see it's executing map, then it'll execute reduce, and so on. Under the hood, it is talking to the yarn. Let me just show you. You can see here it says that connecting to the resource manager, meaning it's talking to yarn and getting its work done using yarn. All right. All right. So that was a quick example. I know that you may not be familiar with this, right? So for some of you, it would be really quick to get started. Now, that's basically how you execute the MapReduce job. You can take a look at the code. This is available as part of our repository. Here, if you go to CloudxLab/Big Data, it is available as part of the GitHub. Okay, so you can take a look at the HDP examples. There you will see Python and Python streaming and Java. Either you could write the Hadoop MapReduce using this or that, but it's not really required, right? Now, if you want to interact with Spark, right, you can either use Spark shell or you can use the other components. Okay, you can use Spark R, you can use Spark SQL, and so on. Okay, let it be. I'm just leaving it there. We'll talk about it in a while. So what we just saw was, right? So Spark was one of the components that we will be we'll talk about it in a while, right? Now, HBase is a NoSQL data store, meaning we can store data inside HBase. We can store data in the form of tables in HBase. So you can simply say HBase shell. Where is my terminal? Here we can say HBase shell, and here there'll be tables which we can take a look and so on. So we can say show tables. What was that? Show tables? No. List star.star. Okay. All right, so you can see these are the list of tables. If I want to take a look at the sales, I can just say scan and sales. I'm just trying to not give you the entire picture. I'm just making sure that you get an idea how to talk to each component. So using Spark, using HBase cell, you can talk to the HBase, right? So this is a NoSQL storage. You can add the data to it. You can upload the data to it and so on. So HBase is a NoSQL data store, meaning it's like a database, And this database, just like MySQL or Microsoft SQL, stores the data into your local file system. Similarly, HBase stores this data onto HDFS, right? Then we have SQL interface. Since it's not possible to keep running MapReduce all the time, we can run SQL queries instead of writing the code. Okay, so this SQL query get converted into the MapReduce internally and get executed on the yarn. Let me just show you very quickly how does Hive looks like. You can just launch Hive either from here, or you can go to Hue and click on Hive query. So both the things are equivalent. Here you can say show table just like normal SQL. So right now you're talking to Hadoop, and this is going to be basically here you are actually interacting with the data on HDFS in a big data environment, right? So here I just showed you that we can utilize the Hadoop ecosystem to do the querying using Hive really easily. All right, so that way the Hive is wonderful thing. You talk to it using SQL, it under the hood writes code for MapReduce, and which gets executed on yarn and query the HDFS data. Even if the data is in petabytes, Hive can get it done using thousands of computers. All right, and you only have to stick to your standard SQL query language. All right, a query from Chaitanya is the difference between Google MapReduce and Hadoop MapReduce. Google MapReduce was just a paper. Hadoop MapReduce was a real implementation of the same. There have been wonderful changes such as breaking down MapReduce into two parts. One is called Yarn, and another is called MapReduce 2. That has been a biggest change and the difference between the standard Google MapReduce paper and the reality. A question from Ashmita is that, so we need to use Web Console only to interact with all the tools, or is there a GUI installed on CloudxLab? The GUI that is available generally in Hadoop ecosystem is Hue, so you can actually talk to Hue, like talk to various components. Like here, I'm talking to the I'm talking to the same component Hive using the SQL query, right? So you have so here I've just executed the select star from NYSE, and I'm just waiting. Okay, it says that there are nothing left in that data. Probably the data has been deleted. So we can talk to various components through the GUI called Hue. A question from Sagar is this console connects to Linux server? Yes. We have provided you a Linux server to which you can log in and use. Okay, so a question from Aram Devan is that, will this video session will be made available for participants? Yes, of course, this will be made available to everyone. A question from Sapna is, what's the difference between Hive and HBase? Hive is just for mainly for query, while HBase is also for database, right? So the challenge is that if you have HDFS, right, there is only files and folders. If you want to store the data in the form of records and you want to manipulate a particular cell value, you cannot do that in HDFS. Therefore, you need a database kind of format, and that's what is HBase. Hive is mostly for querying, okay? Mostly for querying. Basically, it's a nice form. It's a nice form of MapReduce. Although Hive has tried to provide you a way to modify data, but that's not really efficient. Okay, HBase is far more efficient when it comes to handling lots of writes into the various cells and columns and rows. Okay, a question from Mithul is, can you tell the difference between HBase and HDFS? HBase is like the database, while HDFS is like your normal file system. In HDFS, you can store the data in the files and folders. In HDFS, you store the data in the files and folders, while in HBase, you store the data in the form of table, like insert the row, update a particular cell value, and so on, right? A question from Chaitanya is, HBase under Hadoop is NoSQL? Yes. So Hadoop can deal with velocity of data. That's right. Thank you for that question. Yes. A question from Kiran is, so what's the best scenario to use Hive and MapReduce, right? If you are good with Java coding and you want really custom, then you can use MapReduce. But if you just want to use the standard way of processing structured data, then you use Hive. Okay, let's say you want to process the MP3 songs, then probably you will be using MapReduce or Spark. If you are, let's say, doing the CSV processing, there's a comma separated values in a tabular structure. If you want to just query that data, then you will use Hive. Great questions, Key. All right, a question from Abhishek is, how is the data distributed and processed across the cluster? So data distribution is done by HDFS. If you are storing data in HDFS or HBase, the data gets distributed across the clusters. And when we are processing, we generally frame our problems in the form of SQL or group by kind of statements, which gets executed parallelly on various machines using Yarn and MapReduce, and then you get the results. All right, that's how the work happens. The work is done by combined effort of Yarn and MapReduce and HDFS. Question from Ashmita is there any GUI? Yes, you can use the Hue, the one that I just demonstrated to you, for interacting with the various components. So you can use Hue. When you go to my lab, you will see Hue. This is the one that I'm using. All right. A question from Anonymous is, HBase stores the data from HDFS in tabular format. You can say so, but HBase basically stores the data in its own format. Okay, HBase stores the data in the forms of rows and columns in its own format in HDFS. Okay, so you can't really tamper with you can't really load any data into HBase. You will have to use the HBase commands to load data into HBase. You can't just dump a file from CSV format and say that, okay, HBase, that's our HBase storage. No, but you can do the same thing in Hive, right? You can tell the Hive in a select query that here is my file in the CSV format, load that data and do the processing. But HBase, basically just like MySQL, stores the data in local file system in the form of its proprietary format. In the same way, HBase also stores the data in the HDFS in its proprietary format. A question from Asmita is, or only Web Console? No, you can use Hue. A question from Sagar is, what are the other components like Pig, Mahout, Uzi? Let me just describe those. Now, Pig was similar to Hive, but is no longer being used. Basically, it provided a new language called Pig Latin, which was not really sufficient for production cases. Therefore, people stopped it. Then there was Mahout. Mahout was basically machine learning library that has been largely replaced with Spark, and people do not use Mahout anymore. Then there is something called Uzi, because when you have a larger project, you will have to go with many steps, like create folder in HDFS, then run this particular Hive query, do this work in Yarn, do this work in MapReduce, and so on. Therefore, in a typical project, you will have many interactions with the components. That's why you use a workflow engine. Workflow engine can sequence these steps in a very logical format. Also, there are two components called Flume and Scoop. They are for ingesting the data. If you have structured data, you will use Scoop to put the data into Hadoop ecosystem. If you have like unstructured data, which is continuously being pumped into Hadoop, then you will use Flume. All right, that's the ecosystem. Like, for example, when you are building a recommendation engine, first of all, using Flume, you will bring the data to HDFS. Then using Spark, Hive, or Pig, we will clean the data and put it back in the HDFS. Then using a framework like Spark Machine Learning Library, we will do the recommendations. And once recommendations are done, we will take it back and put it back onto our database for the web server. And from that MySQL server, the web server will be reading and showing the results or recommendations to the end users. So this whole thing can be created using Uzi and can be scheduled using Uzi workflow. All right. A question from, does the Spark also use Yarn and HDFS? Yes. Very good question. Moving ahead, this video's link after the completion of this training, and yes, everybody will get the link probably after 12 hours. How it works for freight forwarding. This I need to understand. Yusuf, could you drop me a message on our forum? I would love to answer this question. All right. a question from Srikanth is, to practice all the concepts and get hands-on, how do we play around? Do you provide any sample data of petabyte size? Not petabyte size, but we do provide the data in gigabyte size. Take a look at a folder called /data in the HDFS. A question from Samya is, so when we store something in HBase, is that broken down and maintained by HDFS? That's correct. Yes. A question from Ye is how to end displaying results of a Hive query in the lab web browser. All right, good question. So what you can do is here, while writing a query, you can say limit 10, just like in SQL, and then run it. Okay, that way it'll only display the 100 records. All right, so that was a quick overview of the Hadoop ecosystem. At the same time, we have Hadoop, Apache Spark. Apache Spark is really fast MapReduce, and it has been built on the same paradigm as MapReduce, and it is very well integrated with Hadoop. So Spark is used for processing. So Spark can run on top of Hadoop. It can run on top of Amazon EC2. It can run on top of other distributed operating systems such as Mesos. We call them resource managers. In case your organization does not have Yarn or Amazon or Mesos, even then you can run Spark in a distributed fashion using its standalone cluster manager. So Spark provides its own cluster manager, which is similar to what Yarn is. Okay, Spark can read the data from almost every kind of database. Normal database, HDFS, HBase, Hive, or Cassandra, it can read the data from anywhere. All right, you can talk to Spark using also. So Spark Core can read the data from everywhere. On top of Spark Core, you have additional libraries such as DataFrame. DataFrames are great for representing data in the structured format. Similarly, we have streaming API whereby you can process data which is coming truly fast. And we have machine learning library, which is basically a library that contains the functions to do various kinds of predictive analytics and machine learning. Then we have GraphX. GraphX is for doing the graph processing, finding out which page is more important than the other, finding the common friends using the Facebook graph, and so on. Those kind of complex problems can be solved using GraphX. You can talk to Spark using SQL, SparkR, Java, Python, and Scala.